All right. For those of you who can't see the chat, the link to the materials is right here. There it is again. So I'm going to get started, and then while I'm getting started, it would be great if everyone could go to the link and download the materials. So what we have in there, by the way, is slides. Let me open it up. So the link that I just sent you is to this right here. So we have the slides that we'll look at, which we will look at, but we'll spend more time in code in ArcGIS Pro. And then some data, which is just some 4 columns, basic, really generic data. Some demo code, which we will open and work with in ArcGIS Pro. We have demo code in 2 formats. We have notebooks and also .py files. So if you prefer to open it up in an IDE like PyCharm or IDLE or whatever you have, you can open up the .py files and work from there. Or else, if you're just working in ArcGIS Pro, the notebooks are really easy to use. And so I think it's a little bit better maybe because I'm not sure what people have. And then other sample code are just a bunch of other PY files that I will show you and that you can keep for your own reference. All right. So I have quite the system going on here. I have a second screen up front so I can see the chat. So if anyone has any questions or any issues, please put it in the chat and I will monitor that. And yeah, I think that's what we got to start. Any questions or issues right now? Was anyone not able to get the software? You're just logging in. Okay. Yeah, just log in as you, and then ArcGIS Pro will be on there. And then for anyone online, let's see. So Al-Bashir, I totally forgot to get you the remote desktop instructions. But I don't know of a way to get into the library computers remotely. What I was thinking was for you to maybe just log on to our Centroid computer remotely. And we have Josh was going to hop on to help with some troubleshooting. So let me see if he's here yet. He's not. But when you see a Josh Reiling log on, chat him and he can get you in. And then Danica, you can just watch for the first 15 minutes, hopefully, and then you can get logged in pretty soon. Okay. So let's get in. We'll just start with a couple of slides and then we'll do a little demo. All right, so I think we're officially starting now. So hello, welcome. Did it log in?
Well,
is it saying generating profile or something?
Yeah, it said it could be. Yeah, it said it was. And
were you able to log in?
Like,
I was on signing, but I couldn't access my files. Like there's some network connection or something.
Where were the files?
In my new drive, that drive.
In the U drive?
Yeah.
Oh, these probably don't have it mapped. You might be able to map it though.
Oh,
Yeah, try mapping that.
I just got that.
Okay, yeah, that's
where I need to be.
yep. Yeah, and then somewhere in there should be Pro, and then Chrome, and then you can use that URL. So go to that URL right now before I flip the slide.
You strongly do that.
Yeah. Okay, so for those of you who don't know me, my name is Elizabeth Tulanowski. Hello. Hello. And I am a GIS instructor out of the ESS department in the Warner College of Natural Resources, and I've been doing GIS for like 25 years. Well, I'm coming up on 26, which is really making me feel old. And I started doing Python stuff in 2004. And you would think that for as long as I've been doing Python stuff, I'd be better at it. But, you know, I can get stuff done, but I'm not like a computer scientist. But we're here to just learn the basics of arcpy and Python for ArcGIS to automate geoprocessing. We only have like 3.5 hours today. Given that it's Zoom, we'll probably keep it more like 3 hours today because who wants to man Zoom for that long? And yeah, if there's anything specific that you want to cover, any questions you have, anything that you have to go back to work and like figure out how to do, let me know. We might not solve it today, but at least I can help you work on it. All right, so hopefully everyone can get to the data. It's in the chat. I put it up in the chat before. If anyone needs it again, I can recopy it down in the chat so you can see it. And yeah, just save everything to a good known location on your computer, wherever that might be. All right, so Jeff, you got it? Okay, and Eric, you're getting it?
Is there a place on this computer that's good?
On these machines, I would just say, just put it in the C drive, like in documents or something for now. I don't think there's another better place on these machines. So what we'll cover today, the expectation is that you all know a little bit of like general Python already. And so I'm not going to go into that too much. We're going to really focus on arcpy. So what can arcpy do? But then like, how do we use it? So running tools, basic running tools, getting properties of data, doing things in a loop, accessing values in a table. So just a little bit of the foundation of each of the different types of things that are out there. And then in the end, I'll give you a bunch of resources too, so that you can go forth and conquer all of arcpy on your own. And like I said, if there's anything else that you want to cover, anything specific, let me know. If we don't have time to cover it today, we can work together and I can help you out. Oh yeah. There's a cheat sheet that I have for you. It is not in the Google Drive yet. I just realized that I forgot to copy it in there, but I'll give you a little cheat sheet along with some other resources. I'll send that out to everyone as an email. That way you have it, because I know it's kind of hard to get out of the slides. So stay tuned. Tomorrow I will send you that. All right, for doing GIS with Python, we need a couple of things on whatever machine we're using. So obviously we need to have Python installed. And if you have ArcGIS Pro, which hopefully everyone has, Python comes with it. So when you install ArcGIS Pro, it will install a version of Python along with it. The current version that I told everyone to get for this workshop is ArcGIS Pro 3. And I'm actually not sure what version these machines have. It's coming up. I know in the Warner College, we moved over to version 3, but now that I think of it, the library might be on the older version, but it should be okay. But the version of ArcGIS will kind of dictate what version of Python you're using. So the old ArcMap, for anyone who used that one is using Python version 2.7. And then the newer version of ArcGIS, Pro here is using, I think, 3.7. There was a machine that I was on that was telling me 3.9, and I'm not sure if that was coming from Pro or somewhere else. But if you're on 2.9, if you're on ArcGIS Pro 2.9, it's using Python 3.7. ArcGIS Pro 3 might be using actually version 3.9.
This one 2.8.
It has 2.8. Does it have ArcGIS Pro?
It says ArcGIS Pro, and I expected about.
These machines might have both ArcMap and Pro. So it's possible to have Map and Pro on your machine at the same time, in which case you will have two versions of Python. You'll have both Python 2.8 or 2.7 and 3.7, whatever version goes with that.
It says 3.0.3 is available, but I don't have admin access to the data.
Oh, you have ArcGIS Pro 2.8.
I have, this is
Okay.
ArcGIS Pro 2.8.
Okay, so that should be okay.
That work?
I think so.
Okay.
All right. All right, so in terms of writing code, today we're going to write and play with our code in the ArcGIS Pro notebooks, but you can also use any IDE. So idle is the one that comes with it, and idle is the one where if you went to your search bar and typed in Python idle, maybe. It should be in here. Sometimes it's a little bit weird to show up in the search. You should be able to search for Python idle GUI. And if you have it, it should show up here. So that's one place that you can write code. Another place that you can write code is if you've downloaded it, there's something called PyCharm. PyCharm Community Edition is a free IDE. I don't know that we have it on the machines here, but for anyone working on your own laptop, I find that that's a really good IDE. There's other ones too, like Spider and a couple other ones. But these are the two pretty common ones. There are some things that you can do right from ArcGIS. There's a Python window and then also notebooks. And then from within Field Calculator, you can implement or execute Python expressions in a code block. So you can run, clean up your data or make calculations or turn everything into uppercase and things like that right from Field Calculator in ArcGIS. All right, in terms of why we would want to use Python for GIS, basically automating geoprocessing. So if you have the same task that you need to do over and over, some type of repetitive task or some type of workflow that's got a lot of pieces and you just want to like set it up and let it run, that's a great reason to use Python. Using Python allows us to do GIS and non-GIS tasks together, and it just makes it more streamlined. Anything you might do more than once, use Python for it. For this workshop, the expectation is that you all know a little bit of Python already. So here's some of the list of things I'm hoping you are familiar with already. Basically, like what Python is, the fact that it's object-oriented, the formatting and syntax for general methods and properties, like object.method, and then arguments go in parentheses. Actions can either be a method or a function. The syntax and formatting is a little bit different depending on what you're doing, but things like len or sorting or working with lists, those sorts of things I'm hoping everyone is comfortable with. Working with variables, creating variables, importing modules, so we'll be importing arcpy for today. Things like looping through a list with a for loop or evaluating conditions with an if statement. So we won't really be teaching those things today, but we'll be using them. And I have some sample code and some demo code where it's like partially written for you. So we're not going to be writing a ton of code from scratch. So hopefully if you're not familiar with any of these things, it should be okay. All right, related to those things that I'm hoping you already know, I do have a couple of slides for your reference, kind of filling in some of those gaps. If you are more of a beginner for Python, these are for your reference. I'm not really going to go over them right now, but just the fact that Python is modular, we can import libraries. The link to the basic Python documentation is on here as well. Some screenshot here of just working with strings and how we can create strings and do indexing or slicing. A sample of how you can work with a list and loop through a list. More listing. What an if statement looks like. So just for your reference, if this is new to you, you have it in here. You can take a look at it. Okay. Are there any questions right now? Any Python basics that you need to go over before we dive in to arcpy? Okay. Well, then it's arcpy time. So here's really lame joke in code. Hopefully we're not afraid of snakes. Hopefully we're ready to learn some Python. Okay, so arcpy, of course, is the Esri created site package. It's not just a regular library. They call it a site package because it's so big. It's got all these different pieces, and it's made for and works only with ArcGIS. So in order to use ArcPy and get access to all these methods and functions and tools and classes, you need to have a license of ArcGIS Pro or ArcGIS of some sort on your machine. So if you don't have that today, you'll just have to watch a little bit, but that's kind of what ArcPy is. Basically, ArcPy gets you access to every single tool in the entire toolbox. So the entire geoprocessing pane, every tool in there, the ones with extensions and everything. And it gets you access to a whole ton of methods and properties for accessing spatial data. So things like data properties, getting into a table and accessing values in a table, looping through different types of layers in a geodatabase, getting to spatial reference properties, so many more, and that's just the basic stuff. There's also more with the ArcGIS API, where you can get into more of the online, like working with ArcGIS online data. We're not going to get into that today. That could be a whole workshop of itself. We'll just kind of cover the basics today. All right, so the first thing is, how do you run a tool? How do you run any tool in all of ArcGIS? Just with this right here. Any tool has a set of syntax, a set of arguments that can be entered in. So if you want to run a buffer or a clip like we have on the bottom, it's always going to be arcpy dot. You have to import arcpy into your script, and then it's always going to be arcpy dot, whatever tool you want to run. So you can look it up in the help, and I'll show you that in a second. But you can go arcpy dot buffer, and notice we have this underscore analysis right here. That would be the alias of the toolbox. So if you look in your geoprocessing pane, so you don't have to go into Pro, you can just watch for this part. But if you go into your analysis, go into tools, go into toolboxes. These are all the different toolboxes that contain all the tools that we have access to. And each toolbox has the real name and then a nickname or alias. And so that's where it's coming from, this arcpy.buffer underscore analysis or arcpy.management.clip raster or whatever. That's where it's coming from. So every tool can be run by the tool name, the alias, and then the arguments. And the arguments you can get from the help. I don't know who has all these memorized. I have a few memorized, but I certainly don't have them all memorized. But you can go to the help for any tool. I'm going to go to buffer because it's the one that was on there. You can look at the buffer tool here, but the help is really where you'll get the syntax. You can also just go to the help yourself and search for the tool that you want. But in the tool reference for any tool, and if you scroll down, you'll see parameters. And there's your Python syntax. So once you have access to ArcPy, you import it into your script, you can run any tool with that general formula, that general syntax. And notice it says in here arcpy.analysis.buffer. Either way will work. The way on my slide, I have an example showing both ways. The top way is older, the bottom way is newer, but they both work. So if I wanted to do a buffer, I would pass in my arguments, just like what it says on the help list. So my arguments would be the input, the output, the buffer distance. And then notice I have all of these optional arguments with the curly brackets. Those are optional. It means that you could leave them off if you don't need to use them, or fill them in if you do need to use them. If you need to skip them, there's a way to skip them with an empty string. For buffer in particular, usually we skip line side, line end type. Usually we skip these two, and then we usually want to do a dissolve option. We usually want to dissolve all. And so we'll see what that looks like in a moment in the code for how you can skip that and then continue. If you have any optional arguments that are at the end that you don't need to fill in, you can just leave them off. So in my example here, notice I only have the input, the output, and a buffer distance, and then nothing else. That would work. That would just take all the defaults. So with that formula, I have now taught you how to run about 837 tools. Damn. I feel like we've done a lot in 2 minutes. A couple other things you should know when you're running tools. There's a property called the workspace, the default workspace. So before you start to write code, it's a good idea for some tools, and it's required for other operations to set your default workspace in the code. So arcpy.env.workspace will set this like default location for where the script will look for data and where the script will create output data. What it means is that you can pass in a data set without having to put the full path down here. Because if you have to put the full path in every single time, it'll make your lines of code really long. And then if you ever change it, you'll have to change every single one. So it's nice to have your workspace set at some, parent folder up top. And then you can just reference the individual data sets, the individual layers by their file name down here. Any questions? All right.
Dumb question. What is the lowercase r?
Oh yeah, no, that's a great question. Why is there an R here? The R stands for raw, and so that's a Python construct, I guess. Raw, R-A-W, and it stands for raw, and it's because a single backslash in Python is an escape character. And if you have a single backslash followed by certain other characters, it'll trigger a string related action. Like backslash N will force it to read like a new line. Backslash T will put a tab in. So if you copy and paste your path here, it's really common to copy and paste the path from here into your code, and it'll give you a single backslash, which could mess up your path because it won't read it right.
So the R makes it not do that.
Correct.
Okay.
Yeah, you just stick an R in front, and it's easier than the other two ways that you could fix it. The other two ways that you could fix it will be a double backslash or change every slash to a forward. And that's tedious. Great question. Any other questions so far? All right, well, let's go into some code. So here's where you have choices. We have in the Google Drive, and hopefully you'll have to download it locally. You can't use it straight from the Google Drive. Let me go into here. In your Google Drive, once you download things, you should see a whole bunch of sample code. It's called demo code. Mine is not in the same folder as yours. You have a folder called demo code. So go into your folder called demo code, and you'll see all of this. We're going to do Python demo 1 right now, and you have two choices. You can open the .py file in either PyCharm or idle, or open the notebook somewhere. Open the Python 1. I don't know where I put it. Open the Python 1 demo IPYNV file in ArcGIS Pro. And that's how I'm going to do it. So for that, you'll have to open ArcGIS Pro. So I'll give everyone a minute to do that. Another thing to note is in the Google Drive, there's a thing here called Python Workshop Package. If you do have ArcGIS Pro 3, not 2.8, but if you have version 3, this Python Workshop Package will open up ArcGIS Pro with my stuff. It's like a copy of my project. So you can do that. So here's what you're doing now. You're either opening ArcGIS Pro and making a folder connection to this location, wherever you put your workshop materials, or find your workshop materials and open it in PyCharm or idle.
I got the workshop package. Is it inside there, or did I not?
I would say go back to here. Well, no, you can go download it all. Yeah, that will download everything. including the demo. You must, because we have, ArcGIS Pro, so go right now. And go to the job one here. Okay, and what I think it's best if you go to folders, if you make a folder connection, right click, make a folder connection. Yeah, that folder connection, and make a folder connection to this folder here, this top level. Or, yeah. Okay,
I have a question.
yeah,
That connecting the folder step that I think you just described could you show how to do that on the computer?
absolutely. So once you open ArcGIS Pro, if you just open a blank project, I recommend opening or saving the project in the same folder where the other stuff got downloaded and unzipped to. And then what you want to do is go to your catalog pane on the right click and do add folder connection. What this will do is allow your ArcGIS Pro project to basically make a shortcut to the folder where all the other stuff is.
Makes sense. Thank you.
Yep, and then go browse to it wherever it might be. And you want to single click on the parent folder. Don't double click, it'll actually dig too deep. But single click on the upper level folder for wherever you put your files for today, and then hit OK. And then you'll see the shortcut here and everything inside.
Perfect. Thank you.
Okay. How's everyone else doing? Okay, thanks for the thumbs up. Oh, I was going to. And now we're going to go.
Okay.
And demo code. Yeah, another one. All right, so once you have that folder connection, expand the folder for demo code, and then you should see all these things that I'm highlighting on the right. Mine are the same, I just don't have it in the subfolder. But you should see all these IPYNB files here. If you are not using the notebooks, then you would want to just go in File Explorer, right click, and then open the Python file in PyCharm or idle or whatever you're using. So I will actually do that just so you can see what it looks like in PyCharm. So this is what the Python demo 1 script looks like in PyCharm. And you can see it's got some comments. It's got some places for you to fill stuff in, some blank spaces for you to write some code. And so we'll just write a couple lines of code here. And then I have some sample code at the bottom. What I'm going to stick with will actually be in ArcGIS Pro. I'm going to go to Python demo 1.ipynb, and that is a notebook. And a notebook, if you just double click on it, should open. I'm keeping my fingers crossed. Is it opening for everyone? Yeah, it will initialize kernel for about a minute. I don't know why it's so slow. No, that's fine. So we'll let it load, and it should look like that. We don't necessarily need to make a map and put the layers in the map, but it's kind of nice to be able to see what the data looks like. So I would suggest taking just a second And I'm using whatever map. It should already have a map in there, or you could use insert and insert a new map. But if you take a look again in your catalog pane, you should have a data folder. And the data folder, will have a Fort Collins geodatabase. Oh, does yours have all the stats and stat2 on it? Oh, no, it doesn't. Good. No, that's my own junk. I was like, oh no, I thought I gave you my results. But yeah, you should have like city parks. We'll use city parks right now. So you can just drag that in. And then we will also do something with elementary schools. But just have that map ready so you can look at the data so you know what we're doing and what the output looks like. Don't worry about symbology. No one cares what it looks like. Okay, so we have a map with the data that we're going to use. You can see it's city parks of Fort Collins. And then if we take a look in the Python demo, this is where we can write code. This is one of like a million places where we can write code. Any code we write for doing arcpy stuff, for doing Python in ArcGIS, needs to import arcpy. Try to zoom in there. We'll need to import arcpy. And then notice that the next line here is setting the default workspace. And this will be different for everybody. So what you should do here is grab your own path for where you put that Fort Collins geodatabase. And we have a question about getting the data. So the data should all be in the URL. So the tiny URL should take you here. And there's data, demo code, sample code, and then the slides. So you'll have to download the data and then unzip it. Yeah, this is the Fort Collins GDB. Okay. All right, so what I'm going to do now is grab the location for where my Fort Collins geodatabase is. So I'm going to go to File Explorer. And I'm going to go to the location where I downloaded and unzipped everything, data. I'm going to go to the Fort Collins geodatabase here and then just copy and paste that path. There are other ways you can actually do it from within ArcGIS as well, but I don't know, I find this easier. So I'm going to Control-C and copy the path from File Explorer, and I'm copying the path to the Fort Collins geodatabase. And let me paste it in and make sure everyone's doing okay. All right. Did you get it? Did you download and unzip the data? So check in here. I'll just do it down here. And then go to the data. And then you'll have to unzip it. So right click it, yeah. Right click extract, let it go to where it wants to go, and then copy the path. All right, so I've copied my path, and notice that I have single backslashes, so I'm going to put R in front of it for raw, and that will make it work better. It would be double click on it, and then grab that one, and then that's what you Control C and Control V into the notebook. All right, if we take a look on the right in our catalog pane, we can see all the data that's in Fort Collins GDB, and we can see the real name of things. We're going to use city parks. So let's make a variable. I'm going to call it LYR because I call it LYR in all 4 of the demo scripts. So just call it LYR and set it equal to the name of a feature class in the Fort Collins geodatabase. Yeah,
The thing that I'm in the data is that's really much.
Did you unzip it?
Yeah.
You might have to refresh, but you're right, but refresh. Okay. Then you go into, right, refresh. Yeah. Oh, no. Go back here, go to that folder where you think it should be. I get to unzip it. Double click and do that. So it is, and then double click there. And that's where, it is. Okay, so just, you can just grab it now.
I just.
Oh, but you need to be in quotation. Oh, no, it should be. Yeah.
And then,
So
if
you
I
can
didn't share this, there's,
hit control. And then go all the way back to the left. And click on. Okay.
then I just say return on that. Would you say return now?
We're gonna hit return in just a second.
Oh,
Okay, so we have our first 3 cells of the notebook, and the way notebooks work, which is why some people hate them and some people love them, is you can run little chunks at a time. But if you have a lot of chunks, you have to run each chunk of code one at a time. So what we're gonna do is notice that when you're in a cell of your notebook, if you hit enter, it doesn't do anything. You need to hit shift enter. So shift enter. And if you looked closely, there's a little asterisk that indicates that that cell is running. So here's a moment of truth. When you ran import arcpy, did it work for everybody? Hopefully so. And the asterisk just means that that cell is actively executing. Oh, it's really quick. Yeah, it's super quick. And then let's hit shift enter on the workspace. And we'll hit shift enter on the city parks. So now we've loaded some things into memory. We have our workspace set. We have a variable created for the layer we want to work on. And now we're going to run a buffer. So we were already looking at the buffer tool before. Hold on. I lost my scroll bar. We were already looking at the buffer tool help before, so click on this link if you want to look at it. I'm going to bring it up here. And so this is the syntax for the buffer tool, and we don't need everything. For this, we just want to buffer city parks by a few hundred feet. So we want to provide the input, the output, and then the buffer distance. What I like to do sometimes is just copy the syntax from the help and put it into my code. So I have it in front of me. And then I can type it out myself. So arcpy dot analysis dot buffer. And then what are our input features? What is the input layer that we're trying to buffer here? Feel free to unmute, shout it out. What's the variable we just made?
LYR.
So yeah, we're gonna use LYR as our input. And then for the output, let's say that we want it to be called the same as the input with an underscore buff on the end. So we can do LYR plus sign underscore buff. What that will do is just keep the output name the same, but stick a buff on the end. And then the next parameter is the buffer distance. And so the buffer distance, if you just type in a number, it will do a buffer of that distance in map units. So if you have data in UTM, your map unit is meters, state plane feet. Geographic coordinate systems, if you are cringy enough to use GCS for your data, then it's going to be decimal degrees, which is not very useful. So you can also put in a distance with a unit like that in quotation marks, like a string, and that will let you do any unit you want. 2 miles and so on. What are those units? The units are the same ones that you would see from the dropdown. On the right here, I've opened up the buffer tool again. So any of these units are what can be typed in. And I have version 3 and it has statute miles, but miles by itself works too. So I'm just going to do 200 feet. And that's it. And then hit Shift Enter and it should run. Oh, if you get an error, which you probably won't, but I did, look at the error code. And what is it telling me at the bottom? I already ran this because it's my demo. I already ran through it. It's telling me it already exists. So what do you think the 2 solutions are for that?
Could name it something else or delete layer underscore buff.
Yeah, I could delete it or give it a different name, but neither of those are really ideal. The ideal thing would be to let it overwrite. So secret third option is to let data overwrite. So way up here, back in the cell where I have my workspace, where I'm kind of setting my environments for the code, I can do arcpy.env. arcpy.env. Overwrite output. Did I spell that right? Yeah. arcpy.env.overwrite output and set it equal to true. So this avoids having to delete it yourself. This avoids having to give it a new name and winding up with multiple copies. This will just let it overwrite. In a notebook, I now have to go back and rerun this cell with Shift Enter. And now I can go back to the buffer line down here where I'm running the actual buffer. Shift Enter to rerun it. And it takes a second. It gives me messages and it says it ran correctly. All right. The message does tell me that it ran correctly. But if you're doing some big project where you have a lot of stuff going on, you have users entering like input data, or you want to make sure that something was really done, there's also an arcpy.exist. So I'm just going to copy this, put it here. You can use arcpy.exist to figure out if something is there or not. Arcpy.exist is a way to check for existence of spatially related data. So arcpy.exist will tell me if a folder exists. It'll tell me if a geodatabase is there. It'll tell me if a shapefile is there. It'll tell me if any of these tables or layers inside of a geodatabase are there. Arcpy.exist will not find files that like File Explorer can see. Arcpy.exist would not tell me if a Python file exists. It's only going to be for spatial types of data. Basically, anything that Arc catalog can see, arcpy.exist will recognize. So now let's play around with an if statement. And we want to say, if it exists, let's tell the user that it got named correctly. So we can say, if arcpy.exists, the name of our output, and I'm going to copy and paste it from above. If the name of our output exists, then I can print out a message. A really simple message. All right, pop quiz. How come I don't have to put the full path here? Because I set the working directory up top with arcpy.env.workspace. So any layer that you are looking for, any layer that's going to be an input, any layer that will get created as an output, it will look for it in here or create it in here, depending on the directionality. And so that's why I don't need to put the full path here. Okay, let's take a quick look at the slides again. I have one more slide to show you related to this. The next thing is, what about raster? So what we just did, we ran a buffer tool, super simple, but that basic formula for looking up syntax will work for nearly every tool in the whole toolbox. And I say nearly because some tools that use extensions work a little bit differently. So how many of you use spatial analyst tools for raster? Maybe not. Spatial analyst tools, thanks. Spatial analyst tools for raster data that are being, or that come from, I went right past it, that come from the spatial analyst toolbox. So back to toolboxes. Any tool coming from the spatial analyst toolbox right here, you may not know it, but it requires a special license. It requires a license for the spatial analyst extension. And so for that, you actually have to import something a little bit different. And depending on how licensing is for your ArcGIS Pro, you may also need to check out the extension. The way that I'm logged in, I don't know if you can see it, but see how I'm logged in as me? And I think every one of you is logged in the same way. Like to open the software, you had to log in with your account. The license is already associated with the name, which Danica just mentioned. But if you are working on a concurrent use license where you have a pool of licenses and everyone's sharing licenses, then you have to check it out. So as a best practice, it's better to always check out your extension, just in case you don't know who's going to be running the script and where they'll be running it from. So back to the slide. So for raster data, you have to import arcpy.sa. It's a good practice to check out the extension, just in case someone is on a concurrent use license and not on an individual account. And then when you run the tool, you actually run the tool and it outputs a result in memory. And then you do a .save as a second step to make it permanent. So the snippet that we're looking at here, you have in the sample code, but this is doing some like remote sensing kind of classification on some imagery, but you can see we run it. Oops, I can't click on it. You run a tool here, and we're running this segment mean shift tool. There are the parameters. And notice that we set the output, the result equal to the seg raster. And then in the next line, we do seg raster.save, and it figures out what subfolder it should go into and then makes it the output name. So that's what you need to do anytime you run something from Spatial Analyst. For Network Analyst, you also have to deal with licensing. But for Network Analyst, I don't think you have to do the .save. So let's take a look at the code in the notebook. The very last thing in this demo in the notebook is looking at, looking at this. So we're importing arcpy.sa. We're checking out the extension just to be on the stage side, even though I don't actually need it for my license. We have our workspace set. And in this case, we're going to be doing a density tool on the schools layer. So we have our input layer set to schools, the output density layer that we want to make be the end result. I'm giving that a name up top. And then scroll bar again. And then here's where I actually run the tool. So I run the tool arcpy.sa. So there's an extra piece in there. arcpy.sa, there's the name of the tool. Input layer, and then none for the field. This particular tool actually has a bunch of different parameters, but we're letting them default just for ease. But there's my input layer. And here's the output that gets created in memory. And then on this line is where I save it to my geodatabase. So just know that if you're running raster tools, it's a little bit of a different process. And the idea here is that it makes it in memory so it's faster. And then you might be doing multiple in-memory steps on one data set, and then you want to make it permanent at the end. So if you're building, if I'm doing density and making this KD RAS, and then I'm going to resample it, and then I'm going to clip it, and then I'm going to do something else to it. I can do all those intermediate steps in memory and then save it out just once at the end. Any questions on that?